Hello, in this video we're going to look at the payout annuity formula and rearrange it so that we can answer a new kind of question. Keep in mind that the equation as we have seen it before says that if we know how much money we're going to take out every period, and we know the rate of return while we're taking those payments, we know T, the number of years that we're going to take the payments for, and we also know K, the number of payments per year. If we know all that information, then we can determine how much money needs to be in the account in order to have that much withdrawal on a regular basis. But a lot of times we want to flip that. We want to know, given the fact that we know the principal in the account, the starting value, the total amount, what is the regular withdrawal amount that we could expect? So the question is, what if we already know the balance in the account and we want to know W? So notice this W can be isolated on the right-hand side by doing a little bit of algebra. For example, if we were to multiply both sides by R over K, kind of move it over here, and then we were to divide out by this big, ugly parentheses, we can isolate W. Now, I'm not going to focus on the algebra there. I'm just going to go ahead and move to the new rearranged formula, and it looks like this. It says W is equal to all of this. And basically, this formula says that if I know the starting amount P, the principal in an account, that earns a rate of return R for T years, and we make 12 or K regular payments, it's usually 12 because we're making monthly payments. If we know all of that information, then we'll know what regular withdrawal W we can expect. So what this means is we can use this formula, this version of the formula, to find the monthly payout W that we will get from an annuity that starts with P dollars in it. So that's the background. Let's take a look at an example. Let's say you have $500,000 saved for retirement, and it's in the account right now. If you assume that you can earn 7% interest, compounded monthly, how much will you be able to pull out each month if you want to be able to take withdrawals for 25 years? Now, notice that because we're pulling money out each month, then we know that the 7% interest has to also compound monthly. So the number of times we compound the interest has to match how often we take out withdrawals in the year. So let's take a look at all of the variables that we have for this example. All right, so we'll start with the equation. The withdrawal amount is equal to this expression here. Now, if we look at what's given to us, we can see that the principal, P, is $500,000. That's what's in the account to start with. R is the annual rate, which is 7%. That's what we're earning while we're taking those withdrawals. So we have $500,000 in the account. We take out a little bit each month, but the rest of it is still growing, and it's growing at this annual rate of 7%. Okay, so that's the numerator. If we move down to the denominator, since we're taking monthly withdrawals, K is 12. R, the rate of return, again, is 0.07. So R over K is 0.07 divided by 12. And then we have negative KT. Don't forget that negative sign is there. It's a negative exponent. So we have negative 12 times 25. So this calculation we're going to put into a scientific calculator. When we do so, we get $3,533 and about 90 cents. The calculation looks like this in the Desmos calculator. Relatively straightforward to enter if you're using that site to do your calculations, and it spits out the value over here with several decimal places. And of course, we're going to round and then say the monthly payout amount is $3,533.90. So what we want to focus on here is the fact that if we have a payout annuity, we can rearrange the original formula given to us so that we can calculate the regular withdrawal if we know the principal, the total amount in the account at the start of those withdrawals.